But this is where we left off in the previous video. Now I have a board and we place the X's and O's on the board. But once the board is full, it doesn't automatically reset. That's the first thing. The second thing is we don't really determine the winner either at the end of the game or as we're playing. So if I have three in a row, either this way or this way, or via the diagonals, then I should basically determine who won the game, even before the game finishes. So that's what we're going to do in this video. We're going to now determine who won the game as each player places their own symbol on the board. So let's get right into it. But before we get into that, due to our debugging last time, we actually have some redundant code which I want us to remove. You can see that we have changed turns after placing each and every item, so we don't really have to do that. And it was this way only because we made an error and we had to fix it. And as we were fixing the error, this new fix, which I'm about to put in now, wouldn't work with that error in place. So now that we have everything resolved from the previous video, we can basically take all of this stuff out and just have one of them. So when we place an object on the board, it'll always land on one of these if statements. Then after that, we can change turns. So it'll only come to this point after placing a piece on the board, and we can test this out. So that's why you can take all of those out and just have one out here. So when you place a piece on the board, it's going to land on either one of these. Then after that, it's going to change turns instead of changing turns immediately after placing the item on the board. And we can quickly test this out. So let's do that. So we can still change turns and everything is still fine. Okay, so now let's start. I'm going to call our next function check winner. So you basically want to check who won. You can call the function anything else. That's totally up to you. But let's just call it check winner. And it doesn't take anything. And we're just going to start with it. And up here, I just want us to put some comments so that we have a structured approach to what we're going to do. So we're going to first identify the horizontal winner, and that's sideways. And then we're going to identify the diagonal winner, which is basically the main diagonal, and the other one, the off diagonal. Then we're also going to determine if any of the pieces won in the horizontal direction, which is from top to bottom. So let's see. Let's start with the horizontal winner. Identify horizontal winner. So these are steps, and let's try to follow them. And the next will be identify vertical winner. And we can end it off with the diagonal winner because it might be a bit complex. So let's end with it. Identify diagonal winner. But the board might fill up and we might not necessarily have a winner. So that's when we have a draw. So we have to cover for such a case. Then the last thing is we want to mention who won the game. So the last part would be to mention draw or win. So if X wins, we're going to say X wins. And if O wins, that's what we basically have to do. If we have a draw, we're going to mention that we do indeed have a draw. So now we are going to convert our board. Remember that we have a board that keeps track of everything. We're going to convert this into a NumPy array. And I covered NumPy arrays in my Python for Beginners series. If you're not familiar with that, so you can check that out. And the reason for that is so we can manipulate it and work with diagonals later. And for other basic operations as well, even as we're about to determine the horizontal and vertical winners. So up here, we're going to import NumPy as np. That's just a shorthand which you're going to use. So instead of typing out NumPy each time, you're just going to have np. Okay, and this is where we're going to use it. We're going to come back to our function, check winner, and we're going to create a board array from that array that we have up there that keeps track of the board. Then we're also going to have a string to store our winner. So let's just have it as an empty string for now. Then here is some winner information. We're going to call it winner info. I'm just going to use a dictionary for this. So we want to now figure out which row or column was the win from. So if you win from left to right or horizontally, then that row has a number. And if you win from top to bottom, that column also has a number. So we can just going to keep track of that row column number, and we're going to start it off as at -1 because we don't have a row which corresponds to -1. Remember, we count from 0, so 0, 1, 2 for each of the rows and columns. So -1 currently doesn't correspond to anything. So if -1 is our result, we know that no one won or nothing changed in this dictionary. So that's the reasoning behind that. Then we now want to have a string here which tells you whether the main diagonal or the off diagonal won, if that is the case. So the first one mainly caters for left to right, top to bottom, and then this one caters for diagonals, because a diagonal basically covers a few rows and columns. So it's a mixture. So we just want to have either main or off diagonal to represent the part which we're referring to. All right, so let's get right into it. And so let's start with the rows. So if you have 3 consecutive X's on a row like this, so if you have an X there, then another one, this is a win. And we want to identify this using our board array. And that's what we're going to do next. So we're going to step through this row, check if there are 3 consecutive symbols that are the same, and check this row, then that row. If any of these is filled with 3 consecutive symbols, then that person or that symbol wins, basically, and we have to output that over there. So that's what we're going to determine now. We're literally going to loop through each row, then find the winner. Then we're going to do the same in the vertical direction. We're going to loop through each column and determine if there are symbols in that direction as well. So let's start with the rows because that's what we set up there. The horizontal winner would be our rows. So to do that, I'm going to use a for loop. My for loop is just going to say for row in range. So I know that I have 3 columns. So I'm going to go from 0 to 3. And then I now want to determine if there is a winner until this point. So if there's a winner, then we're just going to get out of this loop. So down here in the for loop, if we determine that someone won in the next round, so if it finds a winner in the second row, it doesn't have to go to the third row. So we can stop the for loop. That's what this is for. So if we find a winner, we can go out of the loop immediately and stop the game. Otherwise, it'll just go to the third loop, and that's just wasting our processing power again. So we don't need it to go to the next row if we already found a row that has a winner. So that's what that is for. You can put a comment if you want for that. So next, this is where it gets a bit complex. It didn't have to be, but this is the most concise way which I thought of. So let me try to explain this next part. All right. So whenever you have set and you define some sort of an array in here, then it gives you the unique elements in that array, dictionary, whatever it is. And so if I have an array here, which has 1, 2, 1, 4, 5, then set will give me the following. It'll give me 1, 2, 4, 5, because these are unique. We have 2 ones, but in terms of uniqueness, we only have 1 of that type. So the unique types in this array are 1, 2, 4, 5. Even if we had more 4s or more 5s or whatever the case, this function basically gives you unique elements as it tells you here. Okay, so we're going to use this now to fetch all the unique elements in a row. So if we have a row and it is filled with x's only, we only expect this to output an x. So if we have x, O, x in a particular row, then the set will have x, O. But if all the elements in that row are x's, then our set will only have x. And this is when we can determine that we have a winner. So we have to check two things. If this has three elements, if it does, then all of the positions in the row have been filled. So that's the first thing. And the second thing is we only have x's. So those are the two checks which we're going to do. And we're also going to check that one of these is not empty. So even this would basically output an X or maybe this, right? And it's possible that you may misread this because you see an X there and no O. So we have to check that all the elements in here are not empty. And we also have to check that they are unique. All places are filled with X's or O's, and that's how we determine the winner. So set brings out the unique elements in a row or column or whatever we give to it, and it's basically going to help us to find the winner. So if we have three of those and it all boils down to one of them, then we have a winner. So this is what our if statement would look like essentially. So if we say if the length of our set of the board array of a particular row, and this notation here basically says, so this notation here says that we are on this row. Let's say row is currently 0. So if row is 0 as we're looping in the for loop, then this colon basically says all of the columns. So this is the particular row, and each row has a column. I can comment this out so I can explain this better on the board. So if we are on this row, you can see that this row is 0, this is row 1, this is row 2, if you start counting at 0. So now that we're here, if I move from this point to that point, this is row 1, column 0. This is row 1, column 1. This is row 1, column 2. So each of these are on the same row, but they have different columns. So once we introduce that colon, we're basically saying we're taking every column which is on this row. So the row is fixed. It's 0 in this case, so it's the top row. So the row is fixed, but we can take any column. And that allows us to take all of the elements that are on that row because we're saying take everything on this row and we don't care what the column is. So it can be this, this, and that. So it will take all of them on that row because each piece or each point here is defined by a row and a column. That's how you can identify it. So if we specify or if we fix the row and we say we don't care what the column is, then it takes all of them. So I just wanted to explain that notation quickly. So in this first part, let's split it up. Length basically finds the number of elements. So finding the number of elements in the set that will be taken out here. So if we have an XO X case, then set will give us, just like I explained, set will give us XO. Then the length of this, so that's what we're applying after this point. So these are sequential. This happens first, then after returning this, we can find the length of that. So this is inside that. So this happens first, then we find the length of that. The length of this is 2. Okay, so we want to find the length and we want it to be 1 because we want all of these to be the same so that the length of this can be 1. So that is our goal. So that's how we determine the winner. So if this returns 1 and none of the elements in there are an empty string. So if none of the elements in that row, so let's change this back to row because it would be wrong to keep it at 0 all the time. So if none of the elements on that specific row or none of the unique elements are this, because remember that we have our board set as these things. So it might identify this as a winner because applying set to this will essentially give us, so if we apply set to this, it'll give us this. And according to our if statement, so let's copy this so that I can explain it next to our if statement. So according to our if statement, this part will give us 1, so it'll pass because set will give us this. And the length of this is, so the length of this is 1. So it'll pass this first condition. So without that second condition, this qualifies as a winner, but the winner is an empty string. And we only have X's and O's to play with and not empty strings. So we have to make sure that when we're determining the winner, our set doesn't pass this condition only to tell us that empty string won, because empty string is not one of the players. So we have to make sure that when we get a length of 1 from the set, that set is not made up of the empty string, because that's how we set up our board array. So once that is so this second condition only ensures that we pass both of the conditions if we only have x's only, so x, 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 or we have o's only. So once again, if we have o's only, then this is what is going to happen. Board array row column will have this, and the set of that will give us this, and the length of that will give us 1, which will pass the first condition of the if statement. Then after that, we see that set of this, which is the same thing, is not equal to this. So this is our set, and it's definitely not equal to a set of an empty string. So it passes both conditions, and therefore we have a winner, and our winner is O, and the same applies for X. So that's why that second condition is very important. Otherwise, we just have a winner from the start, because when we start, all of the rows and columns are filled up with empty strings, which would pass the first condition. So that second condition helps us so that we're sure that our set is only made up of X's or O's. So once we've identified that this person is a winner, we are going to set wherever they are to the first element in that row. So this is how you do that. We add a row which we don't know, and the first column. So it doesn't matter which column you choose because everything on that row is the same. It's XXX or O. So that's why I chose 0. You can choose 1, you can choose 2, it doesn't matter. It's all the same since they are on the same row. Okay, so that's winner, which is a variable which we've already created. Then next, we want to fill in the winner information. So the row or column of choice is the row that corresponds to the winner. So row column number, remember that's one of the properties. Now we set that to this row which we're currently on in the for loop because that's the row that won. Then we're going to also mention the winner info. So whether it's a diagonal, whether it's a row or a column which won in this case. So in our case, a row won. So it's not a diagonal, it's not an off diagonal, it's not a column which won in this particular for loop, in this particular case. So this is the horizontal case. So we can copy our comment so that it's closer to the part where we deal with it. So that's where that would be relevant. So this part deals with the rows. We're looping through all the rows and we're making sure that all the elements in that row are the same and that they're not empty strings. And if that is the case, then that row wins. And we now capture the row where we have a win. And we also mention that it's a row win, not a column win or a diagonal win. So we're going to do the exact same thing for columns. And if you want to pause the video here, please do so and try to attempt the same, but in the column direction. Okay, so whether you attempted that or not, let's continue. So now we're going to do the same, but for columns. And for columns, it's going to be almost the same, but as you might have guessed, we're now going to swap the indices. So now we're going from column 0 to 3, so it'll count from 0, 1, 2, and then we're going to now check in the previous, if we had a winner in the previous iteration of the for loop, then we can break. So if winner is still an empty string, this will fail, so it'll continue with the for loop. But if winner has now been populated like this in the previous run of this particular for loop, then we are going to break the for loop. Or if we've already identified a winner in the rows, there's no need for us to continue with this one. So if this one identifies a winner first, then this one will break immediately as soon as it starts. So it happens in both directions, or in two ways. One could be we've already found the winner above, or another could be we've found a winner in the previous iteration of the current column. Okay, so now we have that, and we're just going to loop through once again. And I've already explained these conditions, but we're now applying them to columns. So the difference will be that our indices are now any row for a specific column then equal to 1, which basically explains the same thing. So I'm just going to quickly do that, but on the board. So if we're on this column, then this is column 0, this is column 1, this is column 2, and this is column 0, row 0, column 0, row 1, and so on. So basically saying that we want to check if the elements on this column are the same. So we fix the column, it's column 0, it's the first one, but the rows are changing. This is row 0, this is row for all of these. If you want to extract all of these, they all have different columns, but they have the same. They all have different rows, but they have the same column. So that's why in our code, the column is fixed, or it's a specific number in our for loop, and we don't really care about the rows. This allows us to fetch all of it from the array or from the board that we created using this numpy array. Okay, so it's the same condition. I just swap the numbers, row starts, then column. In this case, row starts once again, then column, but now we know what the column is and we don't really care what the row is because every element in a column has a different row. Okay, then we're going to do the same thing on this side. So you might have guessed that we're just going to copy the same. So I'm not going to copy, I'm just going to type it again. And you want to ensure that the set is not a set of an empty string, or the only unique element there is not an empty string. Otherwise, it'll always win when we start. So once again, the winner would have been whoever is in that particular column that we identified. So we can choose whatever row. So it can be 0, 1, 2, doesn't matter, but we're on that column and everything on that column is the same. Then the winner information, once again, we're going to fill that in. So let's see, we're going to now take the column number. So that's why we call this row call number, because we didn't want to have row number and column number, because if one of them were the case, if you had a row win, then what would we set row to if, and the other way around? So let's just have one variable or one field to store both. And that's the reasoning behind that. And to now further specify the type of win that we had, then this is where this other field comes in. It's the row column win. And this would have been a column win. Okay, so that's what we have so far. So another thing we're going to do is we are going to reset the board. when it's full, because we have to. We can't just stop the game when it's full. So we can have a draw, we can have a win. Whether we have a win or draw, we have to reset the board after some time. All right, but before we do that, I'm now going to have another variable which I want us to deal with. And that variable will now tell us whether the board is full or not. So we have to keep track of the board and what's happening on it. So let's create, in that same function, let's create a field or a variable called is full. So this is a Boolean. So this is true if there are no empty strings in this array, and flatten just basically converts it into a one-dimensional array. So currently our array is a 2D array. So there are rows and there are columns. So once we call flatten, all of these just go on the same row. So we now just have 9 items on the same row like that once we call flatten. So an example of that, I'll just quickly give you an example. So if you had 1, 2, then in the next row, 3, 4, if you call flatten on this, it will now convert this into 1, 2, 3, 4 on the same row. So if you want to refer to any of these, you just have to use, let's say, x is the name of this, then you just have to use x0 to refer to the first element. You just use x2 to refer to the third one, and so on. But in the first case, you'd have to specify the row on column. So in this first case up here, that has the 1 and 2 at the top, and that, just like we did here, you'd have to specify two things. You'd have to specify the row, then the column, to pick out particulars that index doesn't exist there. So let's say this would be row 1, column 1, which is 2, which is this element there. That's how you'd get it. But in here, you can just specify 1, and that's how you get it. So flatten converts this into this. And that allows us to just use length and stuff like that to figure out how many elements we have and to easily identify things. So after flattening this, we can determine if there's an empty string in there. So if there's an empty string, that means that on our board, we have an unfilled position. Remember, each time when we place an element on the board, we are filling in a position, or that position which we clicked on. So if there is any one position which has not been filled, then it still has the default empty string that we started with. So this basically checks if we have any of those. If there's any unfilled position, then the board is not full. But if there is no empty string in the board, then the board is full. So that's what we're checking for. If there are no empty strings in the board is full. Otherwise, the board is not full. Now we're going to check if the board is full and not winner, which basically checks if we have an empty string there. So if winner would check that we have a string, or this is not an empty string. But if that is an empty string, then this is when we have a draw. So we don't have a winner and the board is full. That's what this checks for. So winner has not been initialized, or it has not been given an assignment, or there's no assignment there. It's still an empty string. So if winner is still an empty string and the board is full according to a condition above, then we have a draw. So this is when we have a draw. Now that we have a draw, we're going to communicate that to the user using a font object. So we're going to use a font object. So this is my variable, and we're going to use Pygame font, and we're going to use this font called Free Sans Bold, TTF, and give it a font size of 16. Then we are going to use that same font object using the render function, which shows the text on the screen. And the render function is going to show us the text draw. We can just display anything you want, and we're going to determine the smoothing of the text. So we want some smooth text, so set that to true. Then we want to set the color of the text. So I'm going to use RGB, red, green, blue. 25500 just sets that to all red and none of the other colors. Once again, you can choose any color of your choice. Then we're going to put this on our screen. So now I have text which we've defined, and we're going to place this text on the screen. So this is the text, and this is where you're going to place the text. This is just a position which I chose with X and Y coordinates. You can choose any other position, but I chose this position on my board. Okay, so an X position of 230 and a Y position of 450. Then I'm going to update my screen using the same line which we have when in which we had in the previous video when we're placing the items on the board. And I want to pause for a bit so that this doesn't just clear in a split second and the user never sees it. So let's pause for 3 seconds or so, and you can choose any time period. So for this, I'm going to import time. So I can use the time function. I'm going to import time, and I just want to pause for 3 seconds. So my screen will display draw, and I'll see it on the screen for 3 seconds. After that, it will clear the board. So that's just what I want to see here. So we're going to set that to sleep for 3 seconds. Then we're going to reset the board. So let's create a function to reset the board. So let's just create it up here. You can create it anywhere. Let's call it reset board. And we want to clear both the array which we have been working with and the screen. So to do that, we're going to fill the screen with white again. So unfortunately, this is how we do it. So it's not like we're going to erase. So we're literally drawing on top of the screen that we have continually. And we're going to draw our lines again. And then we're going to define the board sections again. Then we're going to use the board that we have or that we defined up there. So we're just specifying that that's the board that we're using. And if it makes you feel better, I can take this up, right? Take it up there or here, it's up to you. Then let's clear our board again, or let's take it back to what it was in the beginning. So that's how you'd clear this board, set it all to empty strings again. So I'm just going to copy that and paste it here. So here's what we've done to clear the board. So we filled the screen with white again, so we're painting over it. We redrew our lines and we redefined our board sections. Then we also redefined these positions on the board, which we used empty strings for. So we're clearing everything. Remember, with each placement, we're going to fill this up, X, O, and so on. So we have to take it back so that our functions here don't give us false information. They have to work with a clean slate. So this is our reset function, and we're just going to call it when we have a draw. So before we go any further, let's just test what we have so far. I'm going to call reset board after 3 seconds. So let's test what we have so far. Let's make sure that it does what it's supposed to do. So let me try to have a draw here. So I don't want any of them to win. I'm going to try my best to have that so that I hope, okay, that wins. So that didn't work at all. Okay, so let me try again. Let's see, let's force a draw. It's not as easy as it looks, trust me. So that's an X that I just placed, and that would be an O. Then let me place an X there again, and that would be an O, then an X there. Okay, so that to me looks like a draw. and we're just going to try to replicate that with something else. And so let's call this function check winner. So we just defined it, but we haven't called it. So in here, as we place our things, we're changing turns and so on. But before we change our turn, after the most recent placement, we want to check if there's a winner right there and then before we change turns. Okay, so we just added this before we changed turns so that we can determine if there's a winner or if there's a draw after each placement. So that's what we're going to do now. And I'm going to try my best once again to replicate a draw. So that's an O, that's an X, that's an O, that's an X. Okay, so it seems to have an error because it can't seem to find this file which I just used for the font. Okay, so we ran into an error when we were running that because this is a typo. It should say Sans bold so that it can identify this font. So let's try that again and see what happens now. So I'm going to place that there, then an O, then an X there, and an O there, maybe an X there, and an O there, another X there, O there, then an X, and then we have a draw. So that's what we are aiming for, and then the board clears after 3 seconds. So that looks good to me. So we can continue, and we're now going to deal with the other case where we have a winner. So when we have a winner, we're going to say if winner, then we're going to do the exact same thing. We're going to, so we might as well copy this into its separate function so that we don't have duplicate stuff. The only difference would be the text which we're passing in here. So is it best to optimize this? Then let's do that. Let's optimize this. So let's say, let's create a function called display text so that we don't have duplicate code. Then we're going to pass in the kind of text that we want to have in here, whether it's a win or a draw. So win or draw. Then we're also going to pass in this optional thing, which would be who won. So what should we call this? Character, player. Let's call it player. Then in here, we're going to say if win or draw equals win, then our text to display. So I'm just going to copy this text, which we're going to. So let's copy everything in here because it's basically going to be the same. Okay. So instead of us typing that twice in both the draw and the win blocks, let's just have a function for it so that we call it. So if we have a win, all of this stuff should be the same, really. It should only differ when we have that. Okay. Then this will determine that. Okay. So we might as well just create a variable here called text to display, something like that. Text to display, empty string. Then if it's a win, then here our text would be set to, so we're not really interested in all of this because it's going to be the same. Else if it's a draw, so those are our two options, then we're just going to change this text to display to something else. So these would be our conditions, and those are the only changes which you expect to have. So now in here, our text to display if the person wins is we're going to have player. So we're going to have player in here. I'm going to use an F string, and we're going to have we're going to have player 1. that's going to be our text. But if we have a draw, the text will just say draw. So now in here, we're going to pass in text to display. Okay. So this function will take in whether we have a win or draw, then the player who won in the case of a win. Otherwise, this would be an empty string. Okay. So if we have a win, then that will be our text x1, for example, and that will be passed in here and displayed on the screen. If we have a draw, then our text will just say draw. And then it'll do all of these things, which I've already explained. Okay, so we're just going to call this function now in both the win and draw blocks. So if we have a draw, then this text will be draw, then player will be empty. If you have a win, then we can call the same function with the winner, not the winner first, but a win. And then we have the winner, which will be whatever we figured out up here. And that is it as far as the winner is concerned, at least for our rows and columns, or for vertical and horizontal columns. So this video is getting quite long, so we might need to stop here. So we've mentioned the draw or win, so we've done that now here. So you can put that comment there. The only outstanding thing is determining the diagonal winner. So you can have that as your homework, I guess. And we'll cover that in the next video. So cover this part and the last part, which is just striking out the winning row, column, or diagonal, which is just a nice to have and not really the main functionality of the game. So that's what we'll do in the next and last video of the series. For now, we can focus on having a row and column winners. So let's test our code and see if it does what we expect it to do. So if I have a winner on this row, then expect it to say x1, and that's what it says, and it clears the screen. If I have a winner on this row, expect it to say O1, and that's what we're going to have. So literally testing each of the rows, and that works. So all of the rows work. Now we're going to test each of the columns. So that column works and it's fine. Then we're going to test this one. Then that one works, that column works. Then finally, we're going to test this column here, and the last one works. So we've been able to determine horizontal and vertical winners, as well as basically refactor our code so that we don't have redundancies. And in here, we determine whether we have a draw or a win. So let's just check if the draw still works. So let's try our best to get a draw. So that can go there, that can go there. Then we have a draw, and that works as well. So we now place our elements on the table or on the board, and we can determine whether we have a draw or a win in the columns and rows. And as I said, you can have the diagonal resolution as your homework. We'll cover that in the last video of the series. So if you have any questions about anything we've discussed, if you have any comments at all, feel free to leave them in the comment section, and I'll see you in the next and last video of this series soon.